이 생성형 인공지능과 우리의 미래를 주제로 한 이 서스테이너블 AI 심포지엄 첫 번째 기조발제자를 한번 모시도록 하겠습니다. 멀리서 오셨네요. 호주에서 오셨거든요. 자, 리 히킨. 근데 저 리 히킨이라고 해서 애초에는 한국계인가 중국계인가 좀 그랬었어요. 근데 이제 순수 백인입니다. 네, 호주 분이신데, 자, 리 히킨 마이크로소프트 아시아 테크 앤 팔러시 리더입니다. 야, 큰 박수로 한번 모셔주십시오. 네. 우리 리 히킨 리더는 이 테크계에서 한 30년 이상 경력의 전문가거든요. 그중 마이크로소프트에서 약 17년을 일을 했어요. 그래서 지금 이 직책 이전에는 마이크로소프트 호주에서 기술 최고 임원을 했고요. 그래서 현재는 호주 시드니에서 살면서 이 마이크로소프트 아시아 기술과 정책 리더를 맡고 있습니다. 오늘 발표 주제는 보니까 Sustainable and Responsible AI Ecosystem, right? 맞죠? 네. 큰 박수 한번 보내주십시오, 여러분. 네.
감사합니다. I apologize for being the only person here who doesn't speak Korean. I will speak in English, but hopefully you can hear me okay. Other way. So thank you for the opportunity to address the audience and to speak about the work that Microsoft is doing in sustainable and responsible AI ecosystems. We live in a very difficult time. AI has been around for many years, but has exploded into our lives in the last 18 months. And not just exploded into our working lives, it's exploded into every aspect of our life. It has impacted how society works. It has changed the way political systems are operated. It has created new and different ways for financial systems to be delivered. And of course, it has created an abundance of new technical challenges for organizations and customers of technology organizations alike to think about. And of course, with that, there are many, many risks and concerns and genuinely heartfelt worries about what AI will mean for our lives. In fact, if you look at the list of words on this slide, you may think to yourself, there is too much risk. It is too dangerous. Why can we do this? This is too much to take on. We should stop. But I ask you to ask yourself this question. What is the purpose of our ambition in business and in our lives? It is to move forward. Everything we do in life is to take a risk. We measure the risk, we manage the risk, and we mitigate the risk. And like the saying on my slide says, whilst a ship in a harbour is safe, that is not what ships are built for. And whilst we may all stop and say, AI is too much risk, that is not what we're here for. We're here to figure out how do we take AI and have it help us as human beings, as society, to do more. So that is my approach to responsible AI. How do we make AI our tool that helps us achieve more? As a company, I've worked for Microsoft for many years, 17 years at Microsoft. As a company, I strongly believe that we have deep optimism about what AI can deliver for people, for industry, and for society. And we're already starting to see early stages of that. We see advances in material sciences. We see advances in healthcare. We see advances in education. Opportunity is everywhere. But we are not blind to the issue that responsibility, safety, security are in critical elements of building an AI future. And so as a company and in my job, my role is to balance the opportunity of innovation with the risk of moving too fast. It's not easy. So as a company, we've had a long journey in responsible AI, and I won't talk about every single box on this slide. But our journey started in 2016, when we wrote a document. In fact, you can still download it today. I urge you to read it. It is still a good perspective on the future. It's called The Future Computed. It's a manifesto for the world that we may want to see in the future as we continue forward on a technology journey. Now bear in mind that was written long before generative AI, but it started our journey towards establishing a good and safe approach to building AI inside of our company. We knew that it started with us. If we didn't build our business safely, how could we ever expect anyone else to use our technology and feel safe? And so we've had many steps along the way. One of the most important things we've done is deliver the responsible AI standard. Now, many of you will know, if you work in policy, that one of the most important things you need is a standard, some mechanism by which we can be doing the same thing consistently every single time. And of course, it should be no surprise that in 2023, as you can see on the slide, we really had to accelerate our work in responsible AI as we were all gripped by the generative AI momentum. So we started here with principles. Now I suspect, in fact I know because I've read them, that Korea, and like many other countries and many companies around the world, has a set of principles as a nation and as a country. Principles that define what you hold dear, what you hold important, what you want to be held accountable to. And that is what these principles are. This is what we believe we should be accountable for as a company. Now the top boxes, I think you could apply to any technology scenario. All technology should be fair, reliable, safe, private, secure. But when we think specifically about AI, many of the biggest challenges that many of us face is in understanding who's in control, who is accountable. How do I know that if AI is doing something, that there isn't a human being that I can hold responsible for that action? And transparency. How much do I know about what AI is doing and how it's doing it? How do I know this is AI or not AI? How do I know what the AI was trained to do and what it's capable of? These are the principles to which we hold ourselves to. But principles aren't enough. Principles simply define what's important. They don't tell you how to measure what's important. So that was the next step. We had to think about how do we measure and make sure that we are attaining that level of compliance that we seek. Principles are a start. Standards give you consistency, and if you have a consistent process, you have a process that you can trust because it's always the same. So we built a standard on the principles that we have, and as I said, the standard is something you can freely download and use, and we put it out to the market not as the benchmark or the gold standard for AI, but as a starting point for many organizations to think about building their own AI standard, their own approach to deploying and using AI. And so that led us to build internal corporate mechanisms, ways in which we want to measure ourselves. We built tools to implement and manage AI. Many tools we build are now available as open source tools for everyone else to build safer AI. And then lastly, and perhaps most importantly, we implemented oversight. We put in place a mechanism to make sure that what we say we do, we do. Most importantly, this is the work of the team I'm in, which is called the Office of Responsible AI. And one of our critical learnings about an Office of Responsible AI is it's very easy to think about AI through the lens of risk and therefore put it into the Office of Risk and Compliancy. Or think about AI as a technical opportunity and put it in the hands of the technical team. But we didn't do that. We built an entirely separate office that looks into our engineering business, into our sales business, into our partner business, into our delivery and solutions business, across the whole spectrum of our business, and it has the right to question our business in all of those places. I know because I've been involved in it. I've seen very big deals to Microsoft get stopped because the Office of Responsible AI says, this is not responsible. We are not holding ourselves to our principles. That's why it's important to have it outside of any part of the business. But then, of course, all of that was built in 2021 and before. And something happened in 2022 or 3, I forget my dates now, everything moves so quickly. But we discovered large language models. We discovered ChatGPT. we discovered this idea that we could make AI do things that we never expected it to do. One of the most wonderful aspects of generative AI is it can do pretty much anything we ask it to do as long as we ask it with the right instructions. And sometimes it does things that we didn't even know it could do because we discover a way to ask that question of it. But of course this has led to significant new problems because in the old world of AI, what I will call predictive AI, where you did all the machine learning yourself, and you had the data, you had the model, you did the training, it was a contained experience. You knew everything it was going to do because you knew the data, you knew the training, and you knew the outcome. In generative AI, and largely speaking, large language models, we don't have that visibility. We have a whole new set of challenges to deal with. We learn new words and we consider new aspects of what AI means. We use the word hallucination in our vocabulary now as if it's a normal word. But 2 years ago, nobody described technology as hallucinating. We think about jailbreaking software. We think about manipulation and human-like behavior in software, fake content, deep fakes. These are all very real harms, but new challenges for us to have to deal with from a responsible AI point of view. So, before I dive into the technology layer of how we think about solving these problems, I want to take a step back and make sure we're all understanding how models are actually built, how GPT-4 is actually built. Because I think that often these things are not clear, and we think of AI as being ChatGPT, where of course there's much more to it than that. So we all understand that a model, or a training of a model, requires data, words and text. But there's a misconception that what happens here is we just scrape the internet and just pull random content off websites and read it and train on that data. The data may come from websites, but it's collected and collated into training data sets. It's sort of managed into a single point. The screenshot below is from Hugging Face, where we have just over 100,000 data sets available. These are publicly available, I won't say licensed, that's too strong a word, but available for use under the terms of the license that they offer to train models. And we take that training data set, which contains words, lots and lots and lots of words, and we tokenize it. Tokenizing is a mathematical construct that breaks apart a word into mathematical units, either the most frequently used or the most frequently connected together, or in some cases, the entire word itself. You can see in the examples I gave there, there's no logical construct to it. There's no reason why the S in Samsung and the Amsung would be separated, but that's how they're tokenized. It's a little bit of a black box bit, that bit. But once we tokenize words, now we have not words, but fragments of words. Still language, but fragments of language. But the next phase is the most important phase, is when we turn that into a model. This is where we do the training, and we end up with what we call weights and biases, but often they're referred to as the parameters or the data or the model itself. And we convert those fragments of words into mathematical, numerical representations of those words. At this point now, there is no words in the model. There are no letters in the model. There are mathematical relationships between words and letters based on their weights and their relationship, but that is all. So now we have a model that knows how words look together. We apply reinforcement learning, human feedback. We want the model to know how to talk like a human being, not like a model. We want to teach it what is good and bad, what is the right way to answer a question. For example, early versions of GPT-3, if you said to it, "What is the weather today?" it wouldn't answer the question, it would just repeat another question, because the most logical continuation of a question is another question. So it had to be taught to answer questions. Once we've done the reinforcement learning, we now have a model that is safer, but I wouldn't call it safe. And we wrap around that, we call that a model. And for those of you that are interested, what does a model look like? It's very boring. It's some Python code, it's some JSON strings, it's some tensors and some data sets, but that's essentially what it is. It's a collection of files that then get run to create the model and perform the outputs. So if we understand that that's the journey, and then of course remember that the data and the training data sets are no longer part of the model. The model doesn't have that data in it anymore. It simply has the numbers, the weights and biases. If we understand all of that, then we understand that the model itself is just a very simple, small piece of the overall stack of AI. In this scenario, if we think about what you see on the screen here as being ChatGPT, then the model and the safety system, which I'll talk about, is the platform. And then the ChatGPT experience, the website, the things you see, is the application above that. And the reason why we've looked at it from this point of view is we know that there are going to be many, many more models built. We're already seeing hundreds of models being built. And we know that the concepts of safety and what is safe and harmless or harm-free or the experiences we want to have from AI are not going to come from the models, they're going to come from the way we deploy those models in applications. So it would be foolish of us to try and build models that are safe, because safe for what? Safe for who? Safe for medical usage? Safe for school usage? Safe for defense usage? There is no single bar. So we have to decouple the concept of safety from the model itself and build wrappers around models to ensure that when they're deployed, they can be deployed safely. That doesn't relinquish the need for models to be trained well and trained properly, but we have to think about where the model will be used, not the model itself. Let me pull that apart into more detail. This is an example from our Copilot architecture, so our Microsoft Copilot products. In this scenario, you will see that we've broken it apart. There are the infrastructure at the bottom end, the physical hardware, and then the models themselves. They will come and change as technology changes. We will get new hardware for infrastructure. It'll be cheaper, it'll be faster, there'll be more of it, it'll have a less of an economic, environmental footprint. We'll have to think differently about safety features. As the world evolves and we start to see AI being used more, we're going to think differently about what is safe and how to build safe models. We need to keep that separate from the model. And then of course the user experience is as much a part of that responsible experience as anything else. Knowing that users know this is AI and know how to think about using AI is part of that experience. So let me just pull that content safety layer apart a little bit more. In this scenario here, we have the model at the bottom. Could be anything. Could be GPT-4, could be Mistral, could be Llama, could be Phi, could be anything. And at the top, we have your AI application with a user talking to it. In this scenario, we want to make sure that every time a user communicates with a model through an application you've built on AI, that it goes through a safety layer. And that safety layer allows you, as the deployer of AI, to think about, how do I make sure that people aren't trying to jailbreak my version of the model or my version of the application? How do I ensure that the data I think is private, or that I want to hold the rights to copyright on, I can control that? Or I just simply want to make sure that my model isn't harmful to society or issuing bad instructions. All of those layers of control are outside of the model and allow you to build complex, rich, detailed, safety, responsible, safe capabilities on any model, and it allows you to edit them and change them as the world changes without having to change your model underneath it. So it's designed to be loosely coupled and easy to operate and manage while still giving you responsible controls. And sometimes being responsible isn't just about limiting access and closing off capabilities. Sometimes it's about making new ways for the AI model to find answers and collect information. Some of you may be familiar with the concept retrieval augmentation grounding, or RAG, where the model is able to ingest new information in the prompt as it's being requested. So in this scenario, a user makes a prompt to an AI application. The AI application recognizes that that prompt is requesting knowledge, not an answer, not made up words, but knowledge. And so it goes off, in this case, to a cognitive search index, which may have a vector database or an embedding model of words. But that goes and finds that information from a private data source, not in the cloud, not in the language model, maybe in your business. And it pulls the information from that, it adds it to the prompt, and then it sends that back to the large language model and generates what we call a grounded prompt. So in this scenario, we're being responsible by making sure that an application isn't just making up answers, it's able to respond with some truth to its answers. The other change that responsible AI brought about, that generative AI brought about, was the need for a life cycle. So this is the model we adapt here at Microsoft. We go through a three-phase approach. The first phase is to identify. This is when we perform that assessment based on the principles. We ask ourselves a series of questions and determine the impact of the tool we're building and fairness and reliability, privacy, or any of those principles. Once we've identified the model's impact on those, we want to measure the model's ability to be resilient. Measure is where we do red teaming. Measure is where we push the model to see what it does when something bad or someone bad attempts to communicate with it. Once we've done that, we go through a mitigation process, which might mean more training, might mean a new meta prompt, might mean stronger safety controls, content safety controls. But once we do all of that, then we operate the model. And the big change with generative AI is we can no longer build a model, deploy a model, and then know that it will keep working. We know it will change its behavior over time, and so we have to operate that model and continually check against those principles. Now, I know that for this audience, something of deep interest is the power of AI's challenge to what we now expect of copyright and IP and digital information platforms. This is an interesting time, and we're in the midst of many, many things and many discussions around the world on this topic. What I will give to you is how we think about this today and how we're approaching this situation as an organization. First and foremost, we strongly agree and believe that all AI tools and all AI users must respect copyright. No question about that. But we also believe, under the terms of the law today, that the public has the right to use technology to develop knowledge from copyrighted works. And we have many cited examples over the many years, decades, where that has been the case. And thirdly, and this leans more towards where are we heading with AI, is that these tools must be designed to benefit society broadly, not narrowly. And the reason why that's here in copyright is because that talks to the fact that the value and the quality and the denseness of the data that we use to train models will directly determine the value of that model in its usage in the real world. Now, we've built a program which I won't talk about in detail, called our Copyright Commitment, which is about making sure that if you use our products, we stand behind you to provide indemnification under certain circumstances should you feel an IP, or should you receive an IP litigative response. But this is more about, as you use our products, what you may build out of the back of them. And we've also made some very clear statements on privacy and security. And I apologize if this is not new information to you, but I want to reiterate something very, very important here. Although we are using in our platforms what we would refer to as shared large language models like GPT-4 or other things, no customer data is ever used to train those foundational models in our enterprise services. No customer data is shared between users of those models. We maintain very strict privacy and security channels for every single user in our system. That's the bread and butter of our business. In fact, I tell you now, if we didn't do that, we would not be in business as a company. It's just important. It's just more than important. It is what we have to do. So now when we think about all of these challenges of AI generating information, we have to think about where and how can the public understand the use of AI? How do they know where AI is appearing in their lives? So part of the work we've been doing started with us setting up an organization called Project Origin back in 2020. That has evolved into something called the Coalition for Content Provenance and Authenticity. It's an independent, not-for-profit organization that is building a specification for the meta tagging and watermarking of AI-generated content. It uses something called content credentials, which are much like you would see the metadata tags in your digital photos, and uses watermarking in images and video content to not just determine when content is made by AI, but then track that content through its life cycle so we know where it has been used. The work we really need to focus on now is getting the places where data and information is shared, the platforms where people are reading this information and need to be told that this is AI content, this is not a real video. You need to know that AI created this. That's the next phase of work for the Content Coalition, is to start building out an ecosystem of verifiable AI platforms. Now, one of the other elements of this talk was around sustainable AI, and by that we mean an ecosystem. A sustainable ecosystem that allows for small independent vendors, for open source, for closed source, for Microsoft, for our competitors, for our partners, for everyone to participate. And we do this as much as we can. We contribute deeply to the open source community across our responsible tools, across our research, and of course we publish our own models through open source. Our Phi2 model is an MIT licensed, commercial licensed model, as well as we bring and allow all of the open source models through Hugging Face to be available on our platform. The important thing to remember there is, if you think back to my content safety slide, if you have a model, an open source model on Hugging Face and you use it through Azure, we will enforce content safety on that model, any model. So it allows you to build that responsible layer into your model. And it's not just contributing models and data, it's also contributing innovations in the open source model, because there is a lot of work to be done in making AI more sustainable from the ecological point of view. How do we make sure that we can process AI in more efficient hardware? And much of the work we're doing here as well with our DeepSpeed platform and some of the Onyx cross-platform runtimes is about reducing that environmental burden. I mentioned Phi2, and I didn't want to bring this slide up because we're quite impressed with the numbers, but also it's the next phase of where we're heading. We're looking more now towards small language models. Small language models that have a highly valuable, highly dense, highly rich data set for training and allow us to think about new places to run models and new capabilities to build into models. I don't want to do a product pitch, that's not my job here, but I wanted to just make one thing clear. We talk about Copilot, Microsoft, where everybody from Microsoft will tell you about Copilots. I apologize. We're not very good at making it very clear what we mean by that. So fundamentally, there are two elements of our platform from a responsible AI point of view. There is all of the Copilot products, so Copilot, X used to be called Bing Chat, Copilot Pro, which is like ChatGPT Plus, and Copilot from Microsoft 365 or any of our other platforms. These are products that we offer to you, and we have already done the training, the safety filtering, the protections. They are SaaS products, fully finished products. The Azure OpenAI and the Azure AI Studio are developer platforms where you have the tools and the mechanisms to build all of the safety systems, all of the meta prompts, all of the grounding. You have options to do all of that. But in both cases, the same infrastructure, same safety features are being used. So to really land this point about our commitment to building an ecosystem, it isn't just about us being open source friendly, it's about us contributing to open source and bringing more investment into better open source models and better open source tools. And we're deeply committed to continuing to do that. What we want to see is a vibrant AI ecosystem for startups, for big businesses, for industry, and for government. Because there's a lot of regulation going on. There's a lot of rules being put in place, and we want to help to be part of that conversation. I think this AI moment is one of those unique moments where Our technology and the pursuit of regulation need to work in tandem together. And so I won't talk through every one of these 5 points because I suspect I'm nearly over time, if not already over time. But we have put together a 5-point approach to this, and it's all about collaboration and partnership in this space. We know that AI needs guardrails to protect society, but we also know that AI needs flexibility to address global issues. We need to do both. 감사합니다.